or augmented reality or machine learning, deep learning, and Internet of Things. Okay, all these technologies can be used using embedded systems, or embedded systems will be at the heart of such trends, because what it does is it reduces the energy consumption, improves the security of embedded devices, cloud computing, mesh networking, deep learning application, and visualization tool, because all these technologies can work in a real time. An embedded system is a system which works on which processes the real time data. Okay. Any questions up to this point? Okay. Um, then the next part of embedded system is the classification. So there are different types of systems available. There are different parts of embedded systems available. Few parts are like one of the classification is small scale embedded system. Okay, so small scale embedded systems are designed using 64-bit microcontroller or 16-bit microcontroller. They can be powered by a battery. The processor uses very less or
Sushant
limited
sir, hello.
resources of memory and processing speed.
Hello, Sushant sir, your
Yeah,
screen is not visible. Have you shared your
yeah. So,
PPT? Please share it again.
yeah. Actually, there is a electricity issue, sir.
Okay,
That's why
okay,
I am
okay,
unable
okay,
to
okay,
share
sir,
my
okay,
PPT.
sir, okay.
Yeah, yeah, yeah. Yeah. But I can share it with the ma'am also, so that if it's possible, can one of you share it so that uh,
Sir, you can share this to Swati ma'am. Please share your PPT to Swati ma'am on its
okay,
WhatsApp number.
I'll do that. Okay. Yep, I just shared. Okay. Ma'am, can you share your screen? For that, are you able to open that link? Yeah.
Hello, sir. Are you able to see
Yes,
this
I
PPT?
yes, sir. I can see
Okay,
the
okay,
screen.
okay, okay.
So yeah.
Which slide? Slide number
Slide number 7.
7.
Yeah.
Okay.
Yep. So we were talking about different like classifications of embedded system. Okay. So embedded systems can be of different type, like small scale, medium scale, or sophisticated or large scale complex embedded system. In small scale embedded systems, those those systems are designed or those systems are designed using 8-bit or 64-bit 16-bit microcontroller. Sorry, and they can be powered by a battery. They have a processor which uses less resources of memory and processing speed. Uh, Also, this system does not act as an independent system, and they act as a component of a computer system. So, if 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 any one of you has seen or worked on the microcontroller, then that's a small scale embedded system. Uh, Basically, we have a microcontroller available which is 8-bit or 16-bit. We run different kinds of program for that, but that's not the whole embedded system. It's just a simple single part which needs to be integrated with a much larger system to work. Okay, so that's a good example of small scale embedded system. Now second classification is a medium scale embedded system. So medium scale embedded systems are designed using 16-bit or 32-bit microcontrollers. Okay, these medium scale embedded systems are much faster than small scale embedded systems. Uh, for example, I just showed you the Raspberry Pi and STM32 board. So the Raspberry Pi which I have is a 32-bit. It works on the 32-bit uh, system. Okay, so that's one example. Also, medium scale embedded system can work on programming language, like it can work on C++ or Java. uh, these languages can be used to develop a medium scale embedded systems. Okay, different types of software tools, like if you see a compiler or a debugger or simulator are used to develop this type of systems. So this is the explanation for medium scale embedded system. Okay, next, the most important embedded system and most of the real world and important applications comes under this classification of embedded system. This is complex embedded system, which is really sophisticated or complex, are designed using 32-bit or 64-bit microcontrollers. These systems are developed to perform large scale complex functions. So when I say large scale complex functions, these functions are really important, and it should work at that instant of time, instead of taking seconds of delay. It should work at the same second with a small amount of latency. Since it's an electronic system, it could have a small amount of latency, but it should work between that latency period. Okay, so the sophisticated or complex embedded system uses both hardware and software components to design the final system, uh, or a product. Okay, so this is the classification for uh, embedded systems. Okay, the great example of sophisticated embedded system is missile guided systems. Okay, the or so one of the example of missile guided system is Iron Dome. I'm sure that most of you has heard about Iron Dome, where real-time missiles are detected, and Iron Dome intercepts those missiles in real time, and with accuracy of around more than 80%, it catches to its obstacle, and so basically it takes the feedback. It says what object is coming, if that object is a risk or that object is a friendly object. If it's at risk, if the object which it's coming is a risk, then Iron Dome will intercept that object and it will destroy it in the midair. Okay, that's a great example of the sophisticated embedded system. Okay, so the next time when you hear something about um, the missile operating system, or when you hear something about the spacecrafts, or when you hear something about the heart monitoring system. Okay, so you are seeing application. So these are some of the basic applications which we use in our daily life. uh, Few of these applications are GPS receivers, digital cameras, DVD player, microwave oven, set-top box, gaming console. So we all use these applications in our daily life, but we are unaware that these applications are not only systems, or these applications are not only a camera. It has a complex system inside it, and then complex system which is inside it, it's called as embedded system. Okay, uh, sir, can we go to the next slide? Yep, thanks. Then the most important things, or the most important part of embedded system is the real-time operating system. Okay, so RTOS is a real-time operating system. which can be used in in embedded systems. So what is an RTOS? So uh, RTOS is nothing but it's an operating system. For example, we have Windows 10 with us. It's an operating system. There is a Vista, that's an operating system. There is Windows 7, Windows 10. Those are all operating systems. So RTOS is that kind of operating system which is used in embedded systems. Okay. The difference between a real-time operating system and RTOS is RTOS. The goal of RTOS is different. Okay. What you see in front of your screen, that's the goal of RTOS, or that's what RTOS does. Okay. It does the scheduling. Okay. For example, if there are multiple tasks, real-time operating system RTOS will schedule which task to execute first depending on the priority of task. Okay. It has the dispatch latency. Okay. It has the fast dispatch latency, which means if a task is executing, it will try to dispatch, or it will try to complete it as early as possible. Then there is a memory management and symmetric multiprocessing. One of the great example of real-time operating system is the heart rate monitoring system. Okay. Which are used in the emergency rooms, or which are used in the hospitals. So if you compare your Windows 10, okay, if you compare your Windows 10 with the heart rate monitoring system, you will see that heart rate monitoring system never hangs, because a life depends on heart rate monitoring system, and they can't use Windows 10 there because it's too slow. It takes a lot of time to even reload. When you click something, sometimes it will take a minutes to do some specific task. If we use that kind of operating systems there, then a lot of people, or there will be a lot of casualty there. That's why RTOS is designed, and that's why RTOS is used uh, in this kind of applications, in the medical applications, or in a missile defense system. Okay. Now, sir, can you go to the next slide?
Hello, sir. Good afternoon. Hello.
Am I audible?
Yes, sir.
Okay. So the next slide has nothing but it had the example of one of the real-time operating systems. That example was the Mars Pathfinder. Okay. The Mars Pathfinder, there was a mistake.
Last slide.
There was a mistake.
प्राची को बोल दीजिए.
कर दिया ना मैसेज.
Am I audible?
Yes, sir.
Okay.
Yeah, sir. So some few time left. That's why you continue at least 1 to 2 minutes.
Yeah, it's a last slide, man. It's a last slide. It's just
Yeah,
an
sir.
example of yeah.
Time will be over now, sir. So vote of
Yeah,
thanks.
yeah, definitely.
So I want to share some experience. So, continue, sir. Continue.
Hello.
Hello.
Yeah. I sorry, I
Continue.
couldn't hear you for.
Hello.
Yeah. So basically,
sir,
this is just
few
the
minutes
example.
left. You can continue.
Yeah. It will take only 1 minute. It's just a
Okay,
simple
sir.
example, and
Okay.
yeah. So this is the example of a Mars Pathfinder spacecraft, which was deployed on Mars. So there were few issues which came here in this spacecraft. So it would be really interesting for all of you, like for all of the students, to go through it. If you want what RTOS is, what a real-time operating system is, so there are, you can Google it, the Mars Pathfinder spacecraft and issues with it, and you will be really interested to learn about that and to learn the RTOS and the embedded systems. Yep. So that's all from my side, guys.
Thank you so much, sir. You gave great information about company. I hope this Sage Talk is very efficient and effective for all these students. Thank you so much, sir. As we are doing it online, we can't show